Hello, everybody, and thank you for joining us on today's webinar, Legionella Detection and to Diagnostics. Today, we are going to be talking about Legionella, and it will range from things such as the regulations to it, to detection, to testing, and numerous other things. I have here today with me Dr. Rajiv Sahay. He's the lab director at Environmental Diagnostics Laboratory here at Pure Air Control Services. And before we get started, I do want to make an announcement that for all attendees today who stayed during the entire presentation, there will be a raffle done afterwards, and the lucky winner will receive an Apple iWatch. So make sure you guys are paying attention. You guys stay here for the whole time, and hopefully, you'll be the lucky winner. Um,
And one more thing, hello and welcome. This is Dr. Sahay. This is really nice that we are going to have this webinar today, but in order to win the raffle, you have to also answer the trivia questions right, which Ronnie will be telling in due course of presentation. Go ahead, Ronnie.
Yes, with those trivia questions, we will go ahead and put them in between slides throughout the presentation. They will be referencing points made during the presentation, so make sure you do pay attention for those when you make, so you can answer them correctly. We'll go ahead and start the presentation now. Give an introduction. That's me. My name is Rony Iraq. I have my bachelor's degree in health sciences from the University of South Florida. I've analyzed several thousand environmental samples during my time here at Environmental Diagnostics Laboratory. I have expertise in identifying bacteria, fungi, and other allergens from environmental samples. And I have a couple affiliations that you can see from American Industrial Hygiene Association and the Continental Automated Buildings Association. This is Dr. Sahay. He has 18 years of research and industry experience. He's analyzed over 150,000 environmental samples. He has numerous affiliations, as you can see listed here. He was also a board member on AHIA's, or the American Industrial Hygiene Association's, laboratory accreditation program. His fields of expertise range from aerobiology to mycology to industrial hygiene to public health, and he has also provided expert testimony in the past. The topics we're going to cover today about Legionella are, we have the introduction, we're going to go over detection methods, diagnostics in regards to it, management and regulation of Legionella, and standards and guidelines regarding different organizations who have created those standards in regards to Legionella. So, what is Legionella? Legionella was during the 1976 American Legion Convention in Philadelphia. There was 182 cases and 29 deaths with this mysterious bacteria that sort of infected all these people. Dr. Joseph McDade of the CDC isolated and identified the etiological agent of it, and he named it Legionella bacteria. It's ubiquitous in nature, and it may be several decades old when Legionella was discovered, but even up until this year, even within this past week, we have listed here in August 2015, 12 people died and 119 were infected in Bronx, New York. It was very big news when that happened, and that's kind of why part of what we do these kinds of webinars for, to inform people. To inform industrial hygienists, other laboratory personnel, people who want to go ahead and prevent this kind of thing from happening. Even within the last week, 3 people were infected and one of them died in Hannibal, Missouri. Legionella can be isolated from clinical and environmental samples. Here at Environmental Diagnostics Laboratory, from the name, we do focus on the environmental samples when it comes to Legionella. It's a gram-negative bacteria. It can appear under the microscope as a coccobacilli, which is about 2 to 6 microns long. It's very tiny, to almost like a filamentous structure, which could be up to 20 microns. Legionella consists of 50 species and at least 70 distinct serogroups. While there are that many, not necessarily all of them are ones that will come up or be cause for alarm. There are certain species of Legionella that are a little bit more concerning when they're found compared to others, but you won't be able to tell that until you actually get the testing done and actually do the proper testing to find out. Now, not to alarm you guys listening to us, our audience, but we do have some statistics here to show some numbers about Legionella to kind of give you a better idea of it's not just this kind of hidden thing that happens. There are about 8 to 18,000 cases per year in the United States alone. As you can see on this next bullet point, 90 cases are unreported. 23% are hospital acquired. In regards to that New York news segment, that a lot of people were getting it because of that. 77% of cases are non-hospital acquired. Sometimes those are ones that we here at our laboratory kind of like to do when they're not exactly from any sort of clinical or anything like that, but they just come from the environment, such as the soil or anything, and we'll talk about that later. 20% of cases are travel associated in Europe, and about 10 to 20% of the known infected die from Legionella. So it can be fatal in certain circumstances. On this slide, we have some clinical definitions of what happens with Legionella infections. I don't have it listed here, but an all-encompassing term for these two that you can see, the Pontiac fever and Legionnaire's disease, is called Legionellosis. That can kind of contains both of them. As you see here with mild febrile illness, the Pontiac fever, it's an acute self-limiting illness with flu-like symptoms that include fevers, chills, headache, etc. This can last for about 2 to 5 days and can go away on its own. And that can be part of the reason why a lot of these infections go unreported. Some people just think that they have some sort of fever or they have some sort of flu, and they don't realize that they actually were infected by Legionella, and by the time that it would take to find out, they're already cured. They don't even take a second guess about it. Legionella can also have pneumonia-like symptoms, shows things such as a cough, shortness of breath, high fever, muscle aches, etc., etc. We have all these kinds of symptoms. Once again, they may not seem like they were caused by Legionella, and the symptoms can begin about 2 to 14 days after being exposed to the bacteria. So it may be difficult to find out if it ever was Legionella or something else. And it can also cause Legionella can also cause things such as extrapulmonary syndromes. Extra meaning outside, pulmonary meaning lung. The other two definitions that we have here, they more regard respiratory problems and things like that. Extrapulmonary syndromes could be outside infections, extrapulmonary infections caused by Legionella. The detection of Legionella from a clinical standpoint can be done from urine. As you see here, we have a urinary antigen assay that can be used in order to go ahead and discover it, or it can be from respiratory secretions. Culture can be performed from those kinds of samples in order to detect Legionella. Individuals who could have a higher health risk, we have them listed here, and these people are typically the ones that, as you can see, are kind of more involved or have longer stays or more common stays at hospitals. Individuals who are immunocompromised, they're more susceptible to the disease. Anyone who's over the age of 50, as you start getting older, your immune system can't keep up the way that it used to. And so when your immune system can't fight off any infection, you're more at risk for Legionella. Community outbreaks, if an individual gets infected and starts showing symptoms, there could be methods of transfer between the individuals. There's a certain way that Legionella can transfer, and that can sort of also indicate if one person got sick, let's say from a water source or some sort of fountain or anything like that. That means multiple people could be using or be near that same source, and a community outbreak could appear that way. Individuals with a smoking habit are more susceptible. As I was stating earlier, Legionella kind of has more symptoms when regards to respiratory problems, and so people who smoke sort of have weaker lungs and things like that. So they're more susceptible to Legionella when any sort of bacterial inoculum could get into their body. That kind of also leads into this last bullet point: people suffering from lung disease, COPD, emphysema, etc. Once again, that's dealing with the lungs, weaker lungs. The immune system isn't as strong, or they're more susceptible to breathing in Legionella particulates in aerosolized water. They're more susceptible when it comes to Legionella infection. Now, the part that we're more interested here in our laboratory are environmental detection methods. You find out about the outbreak, or whether it's an individual, the symbiosis that Legionella can have with other bacteria, or the biofilm sediments, which Legionella creates biofilms to allow it to sort of propagate in certain environments. And then we have environmental exposure risk, whether it be contaminated water, where Legionella can sort of aerosolize from any sort of splashing or any other methods of aerosolization. Soil contamination is even possible, where it's a terrestrial problem and not necessarily a liquid water problem. And this last point, aerosolization of the bacteria. That's typically how it gets into an individual and starts causing problems. Now we're going to go into how someone detects growth factors, how people detect Legionella in regards to the sources of Legionella, the growth factors of Legionella, and sampling strategies when trying to get it. But before we go into that, I'm going to go ahead and pull up the first question for you guys. Hopefully you've been paying attention. And let's go ahead and launch the question. Go ahead and give you guys about 30 seconds to go ahead and answer this. The question is, how many cases of Legionella go unreported per year? Is it 25%, 57%, 77%, or 90%? Go ahead and go for about another 10 more seconds. And we're going to close the polls now. So, as you can see here, go ahead and share the results with everyone. Most people did pick answer D, which was 90% go unreported, and that is the correct answer. Good job, guys, for paying attention. Hopefully the rest of you will go ahead and get the rest correct, and maybe hopefully give you guys some good information that you can take with you. All right, I'm going to go ahead and pass it over to Dr. Rajiv Sahay, so that he can go ahead and tell you guys about some detection information.
Again, welcome all of our participants. Ronnie has given an overall idea about the Legionella, and he introduced the organism itself, which represent from the bacterial organisms. And this organisms is very important, as Ronnie was illustrating that how it is important because of their economic importance, meaning a lot of people are getting sick with that bacteria. So the key to identify or study this bacteria is detection, that how you are going to detect this bacteria. So to identify that bacteria, it is very important that you isolate bacteria in such a good condition that you can further analyze and you give a proper taxonomic characterization of that bacteria. So that can be done, I guess, by exploring these three basic points. First of all, we need to pay attention that what are the sources, what are the good places that you are going to have this bacteria. Second one is that under what growth condition it flourishes, meaning what are the optimal growth condition, in other words. And then very important, what kind of sampling strategy you adopt, because that is going to be another key element in the detection, because there aren't a lot of standardization in isolation of bacteria as a whole and Legionella as a particular, but CDC has standardized it, and the laboratory world knows as an elite protocol. We'll discuss that a little later. So for easy understanding, there are two different environments, and today we are not covering the clinical source of this bacteria. Rather, our emphasis is to get our viewer an idea that how this bacteria resides in nature. So as you can see on this particular slide, that there are two different environments. One we call or term as natural environments, and the other one is the environmental that is being man-made, and we term as artificial environment. So natural environment as self-explanatory, such as aquatic, such as pond, lake, groundwater, sea water, etc. That is the natural aquatic environment. And then obviously the terrestrial, which is like the surface environment, which include but not limited to soil, biofilm, etc. Contrary to that, or other environment, which is sort of man-made environment, that also encompasses or have business to do with the water as a storage or water as a main component of that particular environment, such as potable water distribution system. You have cooling tower and evaporative coil or condensers, swimming pool, spa, and hot tubs, HVAC, heating, ventilation, air conditioning systems, healthcare facility, hotels and safe, water park, fountains, other indoor environment where people has uh, decorative piece where you have also water into it, and that can be another source in environment where this bacteria can flourish. So just to give you an idea with the pictorial view, that you see here that the faucet, which everyone in our day-to-day life almost each day see that, but we never pay attention that what is going on, what is behind these scenes. So faucet is one of the place which is identified where the bacteria can flourish, especially by making biofilm. So does the AHU drain pan, like air handler unit, often provided with the drain pan where all the condensed water is going to accumulate. But at the same time, if it is not being properly maintained, then it provides a good environment for the growth of this bacteria. Shower head is the another place where if it is not being taken care on regular basis for hygiene purpose, then that can also provide a good place, good ecological niche in that way for the growth of this particular bacteria. Humidifier is the another place where you can see this bacteria. Those were the indoor side, but if you pay attention towards the outdoor side, then many a time people have artificial pond or fountains, etc. As you can see in this picture, that can also harbor this bacteria, because that can also have the optimal condition for the growth of the bacteria. In the other picture, which is the lower half, is the cooling tower for a big chiller unit or air conditioning unit. The water is there, water is in circulation, and that obviously Legionella thrives in the water, so that can be also serve as a good source. Now, it is very important. I've been asked many times with our viewers and customers that what are the optimal temperature. The optimal growth temperature for this particular bacteria ranges between 32 degrees Celsius to 42 degrees Celsius, which is sort of warm temperature, as you can understand, and this bacteria loves little warm side rather going in the cold side. So in nutshell, if you are having a little bit of warm water, you are more vulnerable to get the Legionella growth, or Legionella growth sort of easy, and that's the optimal range which I just mentioned a minute ago. Now, there is another important factor is the pH. pH is highly important in case of microbial growth, and this particular bacteria uh, grow between 2.7 to 8.5, that's the pH scale, but that is called as optimal range because the bacteria can grow little harsh on either side on the pH scale, but the optimal side is between 5 to 8.5, that has been reported. And then obviously it is a microbes, it is a living thing, so it requires nutrients. So the organic constituents of the water or stagnant water or the source itself provide the nutrition to flourish this bacteria, especially when the biofilm conditions appear, then it grows in symbiosis with the other organic material and other bacteria and other microbes. So that provide the nutrient to this bacteria, and the growth is very much witnessed in those scenarios. Now, it is very important, as I was telling you, that you have to have right strategy to isolate this bacteria. As I was telling you that it is in general very hard to standardize a microbiological method that can be 100% proven for isolating a particular type of or individual bacteria. As I was mentioning you in very beginning that CDC has done a lot of work on that, and they have come up with the elite protocol, which is a technique exclusively designed to isolate the Legionella bacteria from the environment. So that protocol is being widely used by various microbiology laboratories. So does with the Pure Air Environmental Diagnostics Laboratory. They also use the elite protocol for the isolation of bacteria from various environmental sample, exclusively from the water sample. So for designing a sampling strategy, it is very much needed or required is a good investigation the surroundings, meaning the environmental investigation is one of the proposition that you have to be considering, so that it gives you an idea that what is in surrounding, whether it is favorable for the bacteria or not. If it is favorable, chances are good that you will be able to isolate that bacteria. Engineering propagation, that is another very important point that helps identifying the appropriate technique for isolating the Legionella bacteria. It's an old building, new building, what type of water system is there, what type of risk management is there, what kind of hazardous system is there. These things are considered under the engineering propagation. And then the very important point is that whether you are evaluating or investigating this bacteria on proactive basis or reactive basis, meaning you are trying to maintain your facility knowing the pre-hand information that the environment is free from such organisms, or you are evaluating your environment when someone has some concern or someone is complaining or feeling some odd health condition and thinking that they are getting sick due to this bacteria. So that is also very important, and that design that helps the special technique to isolate this bacteria, because in those cases we may want to apply more than one type of technique to isolate the bacteria. I always tells, and CDC also recommend, that the sample collection and transportation must require some proper knowledge and attention. Haven't you heard that there is a theory called as garbage in, garbage out. What I meant by that, if the collection and transportation is not optimized or not done in a right way, then it is going to be troublesome when we will be isolating the bacteria, and we may end up getting not appropriate result or a desired result. The very important point is that system surveillance helps a lot. Like if you have earlier some kind of problem with this kind of bacteria, then you kind of like use a surveillance mechanism to see that whether the measure you have taken is effective or not, and that also help you in designing your sampling strategy. So these are some very important and valuable point, but I think you must know that what are the appropriate method of collecting the sample for this bacteria. And for that I invite Rony to give like little detail on the mechanism how one should consider what type of sample need to be collected. Mr. Rony?
Thank you, Dr. Sahay. Um, from here, we're going to go ahead and, like he was saying, we're going to talk about the actual sample collection. I know there's going to be several or many of you out in the audience right now who will do this kind of thing, who go out into the field, into the hospitals, into the environment, and take these samples in order to test. And these are some methods in order to actually get those, get that Legionella bacteria without sort of contaminating it or messing it up, or sort of doing anything that may not let the Legionella be presented in any sort of results. As you see here, the main way that most people do it for Legionella and that people are mostly concerned with are water samples. You can also do a swab sample. You can use a biofilm sample, and it's also possible to do an air sample with the sample collection. And as you can see here, we have it written in red and italics. You do want to use sterile techniques to prevent what I was saying earlier, any sort of contamination or any results skewing when it comes to the samples. First method for sample collection is water sample. You can collect water from the source by drawing surface water, avoiding, I'm sorry, this hasn't changed. All right, sorry about that. The water sample, it can be done by collecting water from the surface by drawing surface water. You want to avoid any sort of debris or anything like that. You want to use a wide mouth screw cap bottle. You can use a 1 liter bottle to collect from potable water sources. It's also possible to collect a smaller volume of sample from different sources such as cooling towers, non-potable sources, etc. And you can also even go larger with the sample by, well, if Legionella is in low concentrations in things such as municipal water, where the water volume is very large, Legionella may be more distributed throughout it, but you still want to try and detect it. And as a note, sometimes you may need to use sodium thiosulfate for each 1 liter sample in order to neutralize any sort of disinfectant, because if during the transportation there's still disinfectant within that water sample, you may be killing that Legionella without your knowledge, and by the time it gets tested by laboratory, it might come up as a negative result and you won't even know that Legionella is there. We're going to go ahead and ask another question for you guys. Go ahead and put number 2 up on the screen for you. The question is, what is the optimal temperature for the growth of Legionella? We have A is 20 to 25 degrees Celsius, B 32 to 42 degrees Celsius, C 50 to 70 degrees Celsius, and D 80 to 90 degrees Celsius. Go ahead and give you guys another 15 seconds to go ahead and put your answers in. And we will go ahead and close the poll now. Here's the results of that. Looks like most of you guys are paying attention, which is good news. Guess we still got you. We haven't bored you to tears yet. The answer was B, 32 to 42 degrees Celsius is the optimal temperature of growth for Legionella. A lot of water sources, especially in building systems, are around that temperature, which is why it is so important to pay attention to Legionella. Now back to the sample collection. The next sample was a swab sample. That can be done from the point of use, as Dr. Sahay was showing us earlier, from things such as faucets to shower heads, etc. You can go ahead and use a swab and go ahead and put it over that surface and collect anything, any sort of water or any sort of debris that may be on there with that swab. And you want to go ahead and submerge it in 3 to 5 milliliters of water afterwards, and that will go ahead and let you transport it and be able to try and detect it for Legionella. Biofilms are from Legionella when they sort of want to stay in one place because they found a good nutritional source. They can survive there. They can do whatever they need to do there properly, easily. They can be tested by doing bulk samples if you want to just take the entire material and get it tested. By doing a swab sample, like we said, you can just swab the surface, or a wipe or a gauze, something along those lines. It's very similar to a swab, it's just a different sort of method or material. Same sort of thing. You want to go ahead and just put it over the surface and put it into some water so that it will keep the Legionella viable. Then we have air sample as a method of collection. We were saying earlier that Legionella can become aerosolized, and that's how this method could be used. It's not a typical method for use, but it could you could impact Legionella into some sort of media, or you could collect it via the air, and once you get that sample, the laboratory can go ahead and analyze it in order to detect Legionella. This was a point that Dr. Sahay was talking about, the sample storage and transportation. You want to make sure that this is done correctly so that when the Legionella samples are transported from the location to a laboratory for testing, everything is accounted for and everything is done properly in order to prevent any miscommunication or any problems when it comes to finding out if you do have Legionella, and if you do, where the source of Legionella may be coming from. You want to use proper documentation such as a COC, a chain of custody. You want to make sure that the sample is kept at room temperature. You don't want to shock the bacteria in any samples. You don't want to make it too hot. You don't want to make it too cold. That's part of the third bullet point, protected from light. Light can go ahead and affect the growth of certain bacteria, and so if there may be a certain bacteria that responds positively to light, it may overgrow within the sample and sort of inhibit any of the Legionella or possibly kill it. You want to make sure, once again, that's transported at ambient temperature. You want to make sure that's not done in any sort of way that could affect the growth or the results from Legionella. Now, once the samples have gone to a laboratory, as you can see here, we have listed a number of different ways that the Legionella can be analyzed. You can use a non-culture method, which we'll go over some of these, such as direct fluorescence antibody, antigen identification using a rapid test, the culture method, which is the way that we like to do it here in the laboratory, as Dr. Sahay, once again, he was explaining with the CDC Elite. That's the preferred method that they say to do cultures of the samples. So it allows a recovery of bacteria. You can grow it on culture media using a agglutination test for the identification. However, this method is slower. However, it is considered more accurate. It allows proper isolation and identification of Legionella. The last way you can do it is through DNA amplification. You can use polymerase chain reaction, rapid and specific detection. This can give you results within a few hours. However, there isn't much literature or research done using this method, and so it may not always be the preferred method. And we'll go on to the next. So here we're going to go a little bit more into the non-culture method. As we were saying, recovery of bacteria via filtration. You can do antigen antibody reaction, which will allow you to sort of use biochemicals in order to tell whether there's Legionella present. We can use microscopy from a direct sample by performing a gram stain on it and looking at the characteristics under the microscope. However, it may not be exact because there are other bacteria that could have the same characteristics when you're only using microscopy. And this can get you results in a few hours. However, it's very difficult to sort of detect that if there isn't an abundant amount of Legionella within that sample. And before we go on to this next slide, we're going to go ahead and ask question number 3. How is an air sample? Oh, actually, let me go ahead and launch it. Sorry about that. How is an air sample for Legionella collected? We have A, an Anderson sampler, B, a Burkhardt personal sampler, C, a tape sample, or D, none of the above. Go ahead and give you guys about another 15 seconds to go ahead and get your answers in. All right, now we're going to go ahead and close the poll. Share the results. And the correct answer was A, Anderson sampler. That is a method of impinging particle or bacteria that were in the air onto media plates and allowing it to grow. Good job, guys, for those who got it correct. Go ahead and continue now. So the next method that we have is the culture method of samples for Legionella that were received by laboratory. This allows the recovery of bacteria, plating of filtered bacteria so that the concentration is higher. You can have direct plating to see whether Legionella will grow or not. You can perform filtered plating, which will increase the concentration of bacteria to hopefully give you a better growth of Legionella in order to find it or detect it. And an acid treatment of filtrate plating is also used. A very specific solution of acid can be used in a sample in order to sort of kill the bacteria, other bacteria that may be in a sample. However, as we were saying earlier, like Legionella can withstand a pretty low tolerance of, or pretty low pH when it comes to it, so an acid won't affect them as much as, say, other bacteria. These are the methods that the CDC Elite say to use. This is what we do here in our laboratory. We are CDC Elite accredited, and so we use multiple methods, the direct plating, filtered, and acid treatment in order to make sure that if there's Legionella in a sample, it will be detected. That's the examination for the culture of Legionella. The last method that I mentioned was the DNA amplification. This allows the recovery of bacteria. It's amplification of DNA by PCR. So if there may be certain snippets, as you can see in this little photo, of certain DNA, it will go ahead and increase those snippets. As you can see a specific target, there are certain parts of DNA that will identify, hey, yeah, this is Legionella. Unfortunately, like we were saying earlier, there hasn't been much literature and research done on it. Validation on it hasn't been approved by any sort of organization, so it's still being looked at. And although it may be a faster method than the culture, it may not be as reliable until more information is received. Now we're going to go ahead and talk about the diagnostics of Legionella and go ahead and pass it over back to Dr. Sahay, and he will go ahead and explain some of these things.
Well, good job, Ronnie, by giving information regarding the sample collection and what to collect and where to collect, etc. But other important component of this Legionella identification is the diagnostics. The diagnostics basically gives you the information that what are the target or where this bacteria can be located and how we are going to isolate, which Ronnie has already explained that how to do it. So it's sort of a little backward, but I want to emphasize that, like, physical survey is one of the mechanism by which you can eliminate a lot of obvious, and you will be very close to your target when it comes to the isolation of Legionella. We'll discuss a little bit more on the physical survey in the preceding slides. Then clinical versus environmental, as I told you in the very beginning, that this presentation is geared towards uh, the environment or the source of the bacteria, mainly environment, that we are emphasizing. And the other one is that indoor or versus outdoor, like, where we are trying to find the bacteria. So in the physical survey, the key elements are the environmental assessment, environmental exposure, and evidence of disease or outbreak. The environmental assessment encompasses that, like, you start making a physical survey to see what are obvious, which can support the growth of bacteria and which cannot support the growth of the bacteria. So it's a way in kind of factor. So if the factor is indicating that that particular environment where you are doing the evaluation or investigation is having a more favorable than non-favorable, then obviously your chances of getting bacteria is higher than otherwise. The environmental exposure is the another information which helps tremendously. Like, if you find, like, some individuals in and around that facility complaining about, like, the bacterial symptom which goes, like, along with the exposure, then you can write it down, and that would be another good point to scrutinize in order to, isolate the bacteria. Evidence of disease or outbreak obviously is one of the mechanism by which you can respond in a better way when you are doing a reactive uh, or you are in a reactive mode. So reactive mode can definitely helpful to scrutinize that the outbreak or the disease or evidence of the disease, so that we can stop future occurrence of the bacteria. Then in the environmental assessment, there are various components that help. First of all, that you should be paying attention on the surface water, then the building water system, such as potable water and non-potable water system, the HVAC or chiller system. You can also, like, see whether it is like really stagnant water, muddy water, or pure water, or it is being not cleaned properly. And then the thermally polluted lakes and streams are more vulnerable to support the Legionella growth. The indoor versus outdoor mechanism is going to be the another important factor. If you are evaluating the Legionella growth inside the environment, then you should be paying attention on the tab, shower head, valve, eye wash, safety shower, pipe work material, etc., HVAC, evaporating coil, humidifier. These are some main sources where this bacteria can grow. While outside, this bacteria can be flourish in the ornamental fountains, especially when the temperature is a little bit, like, higher. Just say, like, beginning of summer in tropical region. That by the way, there is no periodicity that what season is great for the growth of Legionella outside, but it has been observed that before summer start in tropical region, that the water temperature is a little higher, and that's suitable for the bacterial growth. Your whirlpool, other water sources within or near the facility, such as lake, pond, etc., also harbor these kind of bacteria. Now Ronnie is indicating me that it is a time for his trivia questions, so I will be on pause for a few seconds so that he can go ahead and pull his question, and please try to answer the question.
All right, went ahead and put it up. Question is, what is the most suitable place to collect the Legionella sample? We have A, tabletop, B, back of a chair, C, HVAC or chiller system, and D, none of the above. We'll go ahead and give you guys another 15 seconds to go ahead and answer this. I'm going to go ahead and close the poll and go ahead and share the information, see how everybody did. And it looks like this is the best one yet, with 94% of you saying that it was HVAC/chiller system, and that is the correct answer. Good job, guys. I'm going to go ahead and give it back to Rajiv so we can continue the presentation.
Thank you. Looks like, Ronnie, I'm being, because all these people are paying attention. You get 94% return rate, man. So this is really encouraging. It means people are paying attention on our presentation. Thank you for that. Well, let me continue with the presentation. We were talking about the diagnostics, and I was telling you about the physical survey and the condition. There are a bunch of other factors which is really, really helpful when you are exploring or investigating, evaluating the Legionella, such as a structural and the building engineering has to play a vital role. That you have to pay attention that, like, how the hazard points, or where are the hazard point in a building water system, how the building is being designed, whether the condition is favorable or suitable condition exists inside the building or not. That sort of information is very helpful. Then the potential source of water, what is the main source of water which is, like, coming inside the building. That also help tremendously, whether this water is coming from the ground source, is a municipal water, or is some other source of water. The inspection of the storage tank, water treatment system, and pump, etc., also helpful. Location of water heater and boilers, that is another thing which one should pay attention while designing the isolation or designing the sampling protocol to collect the sample. The fittings used in the system, such as tap, shower, valve, pipe work material, etc., that also helpful, because you have more openings, then you got to collect more sample, because those are the point which might be, like, source for your Legionella growth. And believe me, the routine inspection is one of the good factor one should be keep record on, that helps to design the whole diagnostics. Information procurement from the occupant is another big point which I want to emphasize, because the information from the occupant tells you that whether really problem exists or not, and sort of helps you to determine whether you are doing the proactive mechanism or you are going through the reactive mechanism. The routine building maintenance is the key, because it minimizes the load of these kind of thing. You should be using the good faith approach. Like, you should be honest, try to, like, evaluate the building more frequently than otherwise. Potential environmental source, make a list of those potential environmental sources in the building which might be a source of Legionella itself, so that you can prevent the inoculum, meaning the beginning of the Legionella bacteria, so that they are not going to first of all start contaminating the building water source, and you have a better control over that. Then suspect in the clinical specimen, many a time if somebody is like, suffering from Legionnaires or Pontiac fever, then there is no evidence, by the way, that it is, like, going to man kind of, like, spread. But obviously if someone is susceptible, and the person who is suffering, then if he is going to contaminate any material which other person is going to consume, then the chances get more than otherwise that the person is going to get that particular disease. And obviously everything what you practice must document it, and that documentation obviously help other. If some disease or outbreak happened previously on that place, then you will be more careful. Then at this point, I believe that we are going to give you some more information on the management, on regulation. So Ronnie, you know that there are, like, risks involved with the Legionella, and there are no uniformized or universally accepted standard for the Legionella, simply because this Legionella is not, like, exist, or not a global problem, but the Western country like ours is having a problem, and it's a big problem. So why don't you just give a little bit of introductory remarks on the management?
Of course, Dr. Sahay. Big thing that kind of happened this year, a few months ago, was the release of the ANSI ASHRAE Standard 188 2015. It was released in June of this year. It's meant to minimize the risk associated with Legionella, so it does go over a lot of those things that we've been talking about, and it does have a lot more information such as management and regulation. As Dr. Sahay was saying, it's not exactly universal, but we believe a majority of people will be using this because it is so detailed, and a lot of they had a public review and everything like that, so that there was a lot of input and there's a lot of understanding for it. However, it is not intended for single-family residential buildings. I'm going to go ahead and hand it back over to Dr. Sahay so he can explain a little bit more in regards to it.
Yes, many a time people were like, wondering that how to prevent the risk of Legionella. So ASHRAE standard 188, first of all, let me clarify that it is a mechanism by which you can prevent the growth of Legionella by doing a regular investigation or evaluation. And ASHRAE standard 188, which was released this summer, is basically uh, ask people to pay attention on these following important point. For an example, water management program. As Ronnie said earlier, that this standard, by the way, is not applicable for the single family home. But if it is like a building where people are suspecting Legionella, then to minimize the risk of Legionella, a program need to be in place with the principle that where these problems are really associated with the building water system or not. So that is the first thing we need to do. Then the second point is very important, that is the water building system. The water building system need to be evaluated for a systematic analysis for hazardous condition in the building water system. Then we have to be also aware of the control location, determine the location in the system where control measures are required in case of Legionella outburst happen, and then the control limit, where for each control measure at each control location establish a point that the physical parameter must be monitored and maintained in order to reduce the hazardous condition. So these are some view or good point in this standard. Then obviously this standard call for a monitoring which is associated with the control limits, and then the corrective action if you have really the Legionella problem, that what action is appropriate. For an example, the remediation and other parameter you need to use, you need to give the treatment so that you can get rid of that Legionella or the ongoing problem. And one thing beside others, here is a lot of corrective action and all, but I must say that the documentation and record keeping is one of the things where we need to be, more emphasizing. So I believe, Ronnie, these are some good provision of the standard 188, but why don't you go and continue with some more maintenance and monitoring approach to reduce the risk of Legionella in indoor environment?
All right, Dr. Sahay. As he was saying, in regards to monitoring maintenance, you want to identify any designs or devices suspected for Legionella. Um, Obviously, that there's a big reason for that is because if you think that a certain source or a certain material may be the cause for it, you do want to test for it. A detailed survey for a potential source of Legionella in the existing buildings. Um, there's literature out there that could help you figure that out, or if there's certain parts of a building or something like a hospital, there's only a certain room or a certain wing or anything that there may be a problem, then you'd want to look there more obviously than someplace else. And then you want to implement a procedure for remedial action if there is anything there. And once again, with monitoring, there's to be preventive and reactive actions, and we'll go over that. Things that you may want to do if there is contamination, and then there's Legionellosis cases. And before we go ahead with that, we're going to do our final question. And hopefully you guys are paying attention because this is kind of an important one. What standard on Legionella was released in June 2015? Was it the anti-ASHRAE 190 2015, the 62 2015, the 188 2015, or the 190 1998? And I do want to make a remark that we may go over just a little bit, and we will probably unfortunately have to skip through some of the PowerPoint slides that we have. However, the PowerPoint will be available after the presentation. It's mostly just guidelines and things like that, that if you'd like to, you can reference on your own time and kind of look at it if this is something that you're interested in. Go ahead and close the poll now. Go ahead and share the results. You guys have been doing great lately. 91% of you got the correct answer, which was C, the anti-ASHRAE 188-2015. We'll go back to the PowerPoint. Now, in regards to the maintenance, like we were saying earlier, you have preventative actions such as maintenance of plumbing, the routine checkups, avoiding any sort of sitting water, and the temperature. As we were saying, there's certain temperatures that Legionella likes to stay at. Corrective actions, if there is any sort of Legionella discovered, you want to replace and discard any Legionella infected equipment as biohazard. You want to treat the infected water with a disinfectant. Disinfectant, unfortunately, I work in the laboratory. I don't know so much about the remedial part of it, but there is certain things you may want to look into, such as the selection of the disinfectant. Make sure it's an appropriate one for Legionella. You want to make sure that you apply it correctly, whether it has to go through the system a certain way or anything like that. You want to make sure that it's actually being an effective thing. You want to monitor how well it's working, and you want to do an emergency disinfection if there's any sort of high counts of it. Now, these are the slides I was talking about that are going to involve the guidelines. This is an OSHA guideline, and as you can see, it has different sources of water and how much you may want to follow it. This is different from that anti-ASHRAE one. As I was saying, there's no universal guideline, so there are different ones that you can follow depending on your situation conditions. We're just going to go through these. OSHA, this is what happens if there is Legionella, how you should go about testing and making sure that there isn't any sort of reoccurrence of Legionella. Here is a guideline adapted from HSE, which I believe is a United Kingdom organization who has their own guideline. Once again, we will have this presentation available for you after, so that you may look at these guidelines on your own free time. This is cooling tower Legionella counts. This is another guideline also provided, and there's also excuse me, actions to be taken at certain levels, as you can see here. And then for us, the Environmental Diagnostics Laboratory, we have worked with multiple organizations, different companies, different things. As you can see here, we've done things for federal, state, local, and county governments. We've done things for hospitals, hotel and hospitality, schools, HVAC and other mechanical contractors, and even individual homeowners. So we do have that experience, and if anyone ever has questions, we're always available to answer. Now, I understand that it is about 3 o'clock now, and unfortunately, we understand that some people have very tight schedules, and we do appreciate you guys taking the time to go ahead and listen to us and get some more information. If you guys have any questions, we'll stay here for about a few more minutes or anything. If we don't get to your question, or if you'd like to ask us at a different time, please feel free to email us. This is the sort of family of departments that we have here at Pure Control Services to do many different things when it comes to the Legionella Diagnostics. And here's the information so that you all can see, depending on what you're looking for, we can try and help you as best as we can.
Yeah, I guess, Ronnie, that if any viewer has any question, the contact number is given there. They can shoot me an email and we can respond them. As it was announced earlier that whosoever stayed throughout the presentation and given all the correct answer of the trivia questions qualified for the the award, and then they will be contacted by my office, and we will be announcing the winner later today, and the information will be sent via their contact. So with that, Ronnie, I guess we need to be inviting some more interesting topic if anybody has one. Otherwise, we are very much poised to close today's presentation. What do you think?
I think so. If, like you were saying, if anybody has any questions, feel free to ask us. We're always here to explain. And we do appreciate you all taking time to listen to us and get some knowledge on this very important matter. Thank you.